focusing on today and actually next class period, we're actually going to spend a couple days on this, is factoring. Factoring is where, it's kind of like the opposite of distributive property. Like, you know, you have distributive property, you have two things. You take the outside term and you multiply it to each inside term. Well, what we're going to have instead is what that inside term was all multiplied out, and you want to pull out then the items that you can multiply together. So factoring has to do with like the product. If you think like the number 10 or the number 20, like the number 20, let's look at number 20. The number 20 is a composite or is made up of the product of different numbers. So a factor of 20 could be 20 and 1, it could be 10 and 2, or it could be 5 and 4, right? So what we're looking at, we're going to be looking at expressions that have a composite, meaning two things were multiplied together to make it, okay? So what we're going to try and do is find what those are, what might be those products of those two elements, okay? And factoring is actually something that is very useful, especially like I'm going to reference the Denver Marathon again. When they had the Denver Marathon going in a half marathon and then a marathon, and they were on the same loop, they were every single aid station, every single anytime they had something for help for one, it was helping both races, right? They both got to share each station, right? When they changed the route where the marathon went from the top down, all of a sudden the marathon had half of it that it wasn't sharing with the half marathon anymore, right? So what they had to do was pull out the similarities to know what was left over that they actually had to account for, okay? So that is a prime example of like, okay, what are they sharing? That's kind of like the factor, that's the multiple, that's the composite, versus then what's left over is what you have to deal with separately, worry about costs, units, like what are the things we have to account for, okay? So when you separate, when you factor, you actually are finding the similarities of different things that then you can make it more simple to find out what you actually need to address. It happens a lot like in the clothing industry. You guys have clothing as patterns. If you're using like similar patterns or things like that, what are things that are repetitive? Those we can deal with. It's the things that aren't repetitive that we'd have to account for separately. Set up different machines, separate different type of stitching, things like that. So factoring is actually something they use every single day. It's to make things more simple to find out what you actually have to account for separately. Okay, so you pull it apart and then you can reduce it down. So that's what we're going to be doing over the next week. Okay. There's a lot of different ways that you can actually factor. We're going to start from the number one way you want to do it all the way down to different ways. Okay. When we start with factoring, the very first thing we want to look at is the greatest common factor. So what we're going to be starting with is having an expression in front of us that has a lot of terms. And what you're going to want to do is find a way to make it more simple. So we look to say, what is the greatest common factor? Does anyone remember what it means by greatest common factor? What is it, Brad?
So there's a number that is divisible between all of the.
Yeah, it's something that you can take out of every single term, the highest value, so it can be a number or it can be a term, an actual variable itself. What is the highest that you could take out and divide all terms by it, okay? And so if you look at, let's say, 10 and 20, the greatest common factor between 10 and 20 would be 10, because I can take a 10 out of 10, I can take a 10 out of 20, right? So we're going to look at each one of these, and you're going to look at the coefficient, and you're going to also look at the actual variable itself, okay? So when looking at the greatest common factor for number one, what is the greatest common coefficient number that can be pulled out of 4 and a negative 2? A 2. Okay. And what is the greatest common factor in regards to the variable you could pull out? G. Okay. So 2G is common both in the 4G squared and the negative 2G, right? That's common between both. If I pull that out, it's kind of like the opposite of the distributive property. Then you want to have the term on the left side, and then the inside you'll have what's left over. So you have to ask yourself, if I took this 2G, what do I need to multiply it by to actually make 4G squared? What would this term need to be? It would need to be 2 and then a G, because 2 times 2 gives me 4, and G times G would give me G squared, right? Alright, if I pull a 2G out of this negative 2G, what would I have to multiply 2G by to actually make it equal negative 2G? A negative 1. It'd be negative because this is positive and the inside term needs to be negative. So then I'm only pulling out the positive, so the negative stays. So a negative 2g, so a 2g times a negative 1 will give me negative 2g. And if I then do the distributive property after I've done this, I should get the same answer. So that's your check. So if I take 2g and multiply 2g, do I get 4g squared? I do. If I take a 2g and multiply negative 1, do I get a negative 2g? I do. So once you pull it, you should be able to do the distributive property and make sure you have the right answer. So it should be like a full circle. Okay? Good so far? Alright, let's try number 2. Number 2 is 12x minus 9x cubed plus 15x squared. Okay? So let's look at the coefficients. Is there any, what's the highest number, if anything, that I could pull out of all three of those? A 3? I could pull a 3, right? So let's pull out a 3. So if I pull out a 3, okay. Alright, now let's look at the variables. What's the highest variable I could pull out? An x. Now here's the key on greatest common factors in regards to variables. If the variable is in all terms, you can pull out as many as the lowest exponent variable. So here I have an exponent of 1, 3, and 2. So that means I could pull out a 1. If it was like 2, 3, and 5, I could pull out a 2. So you're always going to look, if the variable exists in all terms, you can pull out as many as the lowest exponent that's there. Does that make sense? Okay. So if I pull out a 3x, I'm going to look to my 12x. What would I need to multiply 3x by to actually make it equal 12x? 4. If I pull out a 3x, I have negative 9x cubed. What would I need to multiply 3x by to make it negative 9x cubed? I'd have to be a negative 3, right, because that will give it a negative 9. And then what would I have to do what would I have to multiply x by? How many x's? X squared. Okay, because remember the rule is to add, so if I'm taking one away, I just take one away from there. Alright, and then it's going to be a positive number here because it's positive. What do I need to multiply 3x by to make it 15x squared? What number? 5, right? 3 times 5 would be 15. And then how many x's? Just one x, right? So I have 3x. I have 4 minus 3x squared plus 5x. If I would do the distributive property, I should get the same value. Alright, so 3x times 4 is 12x. 3x times negative 9x squared is negative 9x cubed. And 3x times 5x is plus 15x squared. Good so far on that? Okay? So that's the greatest common factor. That's the number one thing you want to look at. For any one of these, you want to ask yourself from the very beginning, is there a greatest common factor I can pull out first? If so, pull it out. Okay? It always will then go on the left-hand side. Make sure that gets carried with everything else that you do. Okay? Alright, so then we have a couple of situations that if you can see them right away, they make breaking it out into the factors really easily. Okay? So if I have a variable plus or minus a constant. Okay, so notice how these I had multiple terms. Here I just have 2. There's just a variable and then there's a number. In a situation like this, the very first thing I'm going to ask is there a greatest common factor? Okay, I don't see a greatest common factor either one of those because there's no number I can really pull out and there's a variable is not in each one of them, right? So then I would move on. If I have a variable and a number, I'm going to ask myself, does it fall underneath the difference of the squares? That's what this means, difference of the squares. And what the difference of the squares is, it's a situation that if both of the first and the second term are perfect squares and it's a minus in the middle, you actually can just automatically just look at it and set it up. And I'll show you how that works. So is x squared a perfect square? Meaning, is there anything times itself that would give me x squared? Yes, x times x, right? So a perfect square is going to be something along the lines of, like if it's a variable, x times x gives you x squared times x squared gives you x to the fourth, x to the third times x to the third gives you x to the ninth, right? So perfect square is where the square root of it is a perfect number, it's a whole number, right? So x squared is a perfect square. Is 1 a perfect square? Yeah, 1 times 1, right? So when I have a situation like that and the middle term is a minus sign, I have a situation that's called the difference of the squares, in which my factor is automatically going to be written as the square root of both of those. So the square root of x squared is going to be x, and I'll just put 1 on each side. And then the square root of 1 is just 1, right? Because it's a minus sign here, one of them will be a negative and one of them will be a positive. And the reason why this works is if I do the distributive property, I would get x times x is x squared, right? I'll get an x times 1, which is plus x. I'll get a negative x, and then I'll get a negative 1. My middle terms here cross out, because a positive and negative equals 0, right? So in the end, that ends up being x squared minus 1. So if you can recognize this, when you see an exponent, or a term with an exponent, you have a negative and then a value. If you can evaluate those to be both perfect squares, you can automatically just rewrite it by taking the square root of both and then putting a minus and a plus in between. And you'll automatically have the factors. Okay? So let's look at number 2. Alright, number 2 has a variable with an exponent, and then it has a minus a number. So I'm going to ask myself, is this a perfect square? Is 4m squared a perfect square? It is. What's the perfect square of 4m squared? 2m. So 2m and 2m. So I take the square root of that number. Alright? Is 9 a perfect square? Yeah. What times itself gives you 9? 3. So 3 goes here, 3 goes here. And then 1's a minus, 1's a positive. It doesn't matter which is which. You can make this positive, that minus, it doesn't matter. And that's how easily you can take that number and break it out into its factors. Because the middle terms will cancel, and I'll have the 2m times 2m, which is 4m squared. I'll have the negative 3 times the 3, which is negative 9. Does that make sense? Alright. So let's look at number 3. Okay. Number 3, let's ask ourselves first, is there a greatest common factor? Is there a greatest common factor on number 3? There is. What's the greatest common factor on that? 4. So let's pull a 4 out. If I pull a 4 out, what is left? X squared minus 100, right? Alright. Now, looking at this value here, do I have a perfect square? I do. Do I have a perfect square here? I do. So I can break this down even farther. So what's the perfect square for x squared? X. And then what's the perfect square for 100? 10. So I have a minus and a plus. Again, it doesn't matter which one. And then carry the 4 down. Okay? And so I would have 4 times x minus 10, x plus 10. Alright, so let's look at number 4. So looking at number 4. So my first question, is there a greatest common factor? There is. What is it? 2y. Notice how I have 2 that I can take out of both, right? And then notice I have y I can take out of both. When I take out a 2y, what am I left with? Y to the 4th minus 25. Okay. Is xy to the 4th a perfect square? It is. Is 25 a perfect square? It is. So how could I write y to the 4th minus 25? Well, how would I rewrite that?
Y squared plus 5, y squared.
Yep, y squared plus 5 and y squared minus 5. And then bring down the 2y. Don't lose that. Okay, I'm going to keep that. Okay, and that would be your final answer there. And you wouldn't have seen that up here if you didn't pull out the greatest common factor first. Right? Okay, questions on those? So now what we're going to do is we're going to look at, we had the two things we looked at first, the greatest common factor, the difference of the squares. That's like a special situation. Then we get down to where you have a trinomial, which is 3 terms, okay? And in the 3 terms, you usually have a variable with a higher exponent, and then you have one with a variable with a medium exponent, and then you have a constant. Sometimes it's squared 1, sometimes it's 4 to the square, whatever. So there's a lot of different varieties, okay? So we're going to look at the situation in which your coefficient, your leading coefficient, right, that's the one in front of the highest exponent, is 1, okay? So the very first thing we're going to do is start evaluating that. Now, I don't know if you guys are familiar or like this. Do you guys remember the crisscross? Anybody remember use that at all, or no? Okay. Well, I'm going to do it both ways, so you decide which way you like the best. So basically what we do is when we have a trinomial, the very first thing you want to do is put it in standard form. Okay, so standard form, put in standard form first, which is the highest exponent to the lowest, right? Is this one in standard form?
Mm-hmm.
Okay. Now, standard form, if you can remember, is ax squared plus bx, or bx plus c. Okay, so ax squared plus bx plus c. That's standard form. Where the value in front of the x squared is, we call it a. The value in front of x is b, and then the constant is c. And those are just ways of saying it so that when we talk about what to do next, it makes more sense. What we want to do when we're trying to factor a trinomial is we want to find a number that when I multiply them together, I'll multiply a and c together. If I add them, I'll get b. Okay? So when we multiply a and c together, I'm going to get negative 10, and b is going to be 3. So I need to find two numbers that make up negative 10 when multiplied, but when I add, they're going to equal 3. So this is an add, and this is a multiply. Okay? So I'm going to look at factors of negative 10. Well, what are factors of negative 10? Negative 10, 1, 10, negative 1. What else?
2, 5,
Negative 5, 2, 5, negative 2. Okay? So you're trying to break down all those different factors of negative 10. So those will multiply together and give me negative 10, correct? But when I add them together, do I get 3? Do I get 3 when I add negative 10 and 1? No. Do I get 3 between 10 and negative 1? No. Do I get 3 with negative 5 and 2? No. But do I get 3 with 5 and negative 2? I do. So I'm going to put 5 and negative 2 here. So whatever numbers that actually when multiplied give me the top and when added give me the bottom, those are going to be my factors. And so all I do is rewrite the term with my x's on each one. Okay, because it's x squared. Take the square root of that number. And then I write the middle terms. And it doesn't matter which order I write them in, but you need to make sure the signs are correct. Like I could have said x minus 2 first and then x plus 5. But if this is a positive, that has to be a positive. If that's a negative, that's a negative. Okay? And then if I would do the distributive property, that would work. X times x would give me x squared. X times a negative 2 gives me negative 2x. And then I have a 5x, which then gives me that positive 3x. And then I have a 5 times a negative 2, which gives me negative 10. So when I do the distributive property, then that actually gives me the same answer, and that's my check. Okay? Questions on that? Alright, so let's look at number 2. So what's going to be my value that would go on top? It's going to be 14. It's going to be my A times my C, and the bottom is going to be my B. So I need factors that when multiplied give me 14, and when added give me negative 9. So I have 14, 1. I have 7 and 2. So which one of those might give me a negative 9 somewhere? Negative 7, negative 2, when added, give me negative 9. When I multiply negative 7 to negative 2, do I get a positive 14? I do. So this becomes negative 7, this becomes negative 2. So then, I create my factors. I take the square root of the first term. What's the square root of m to the 4th? M squared. Okay, and then I have a minus 7 and a minus 2 because these become my middle term. Okay? Does that make sense? Alright, so what I'd like you guys to try and do is 3 and 4. Alright, so we have number 1, is it in standard form? Number 2 is going to be greatest common factor. And then number 3 is going to be factoring, right? Okay, so I want you guys to try and go through these and see if you can get an answer for 3 and 4. Okay, so in looking at number 3, I have a trinomial, so I'm going to ask myself, is it standard form? And the answer is yes, because it goes the highest exponent down to the lowest. Then I want to ask myself, is there a greatest common factor I can pull out? Is there something that's common amongst all 3 terms? Well, a 2 can go into all of them, and that's it, because there's no other, x is not in all 3. So I'm going to pull out a 2. When I pull out a 2, I can rewrite this as x squared minus 8x minus 20. So now I'm looking for, when I multiply a and c, negative 20, and when I add, I get negative 8. So I need multiples of 20, then when I add them together, I can get 8. So 10 and 2 are the one that come to my mind, because 20 and 1 would not get me 8, 10 and 2 would possibly give me 8, and 5 and 4 would not give me 8, they would give me 9. So I'll do 10 and 2. Well, the 20 has to be negative, so one of these is negative, and yet my number on the bottom needs to be negative 8. So my negative needs to fall in the 10, because a negative 10 plus a 2 would give me negative 8. When I multiply negative 10 and 2, I'll get negative 20. So therefore, this is my middle term here. So I can rewrite this, bring the 2 down, don't lose it, and then I'll rewrite my middle term. Square root of a is going to be the x squared, x, not x squared. Okay, so that'll be x on this side, and then I'll have x over here, and then I'll have minus 10 and plus 2. Okay? On number 4, I'm going to look here. Is it in standard form? 3, 2, 1. Yep. So that's good. Greatest common factor. Well, let's see. Looks like a 3 can get pulled out of here. And it also looks like a y can get pulled out of here, doesn't it? I have a y cubed, a y squared, and a y. So y is common between all 3, so pull a y out. And then I'm left with y squared plus 11y plus 30. Right? So now I'm going to look for the 30 on top and then 11 on the bottom. So what times what will give me 30, but when I add it together I'll get 11. What are factors of 30? 5 and 6. Okay, so now I know those are my middle terms. So I'm going to have an x plus 5, or sorry, y plus 5 and a y plus 6, and then I got to bring the 3y down. That has to stay with it, because when you pull out a factor, you want to make sure it stays with it, because otherwise you'll change the equation. Okay? Questions on any of these and what we did? No? Okay, we're going to flip. We're going to try one more type of factoring, then I'll let you guys do your homework. I think this is the easiest of them all, to me. That's just me. This is when you have 4. Like, notice I have 4 terms now. Okay? 1, 2, 3, 4. When you have 4 terms, what you want to do is put it in standard form. Okay, so standard form. Okay, and then I want to see if there's any greatest common factor I can pull out. I don't see any greatest common factor in that, so I'm going to move on. Okay, so I look at those. So then, when it's 4, all I'm going to do is divide it in half. I'm going to take a little line, I'm just going to divide it in half. Okay? And then I'm going to look at each side separately in regards to pulling out a greatest common factor. Okay? So if I look at x cubed and 2x squared, is there a greatest common factor in those? X squared. So I'm pulling x squared out. What am I left with on the inside then? I'm left with x plus 2. Right? So I'm going to divide it in 2, and then I'm going to look at each one separately and pull out the greatest common factors. Okay? So now I'm going to look to the other side. Well, the other side, I'm going to ask myself, is there a greatest common factor? Is there anything I can pull out of either one of those? A 3. So I can pull out a 3, so I'll do plus 3. And then what am I left with? X plus 2. Okay. So notice how I have these two expressions here, right? Well, if I had, let's say I had 3a plus 6a. If I have that and I asked you what the greatest common factor was, what would you say? You'd say it's 3a, right? And so I can pull a 3 and an a, and I'm left with 2 plus, no, I'm left with 1 plus 2. 1 plus 2, right? So I can actually pull out a. Well, this is the same situation. Because it's being multiplied, this x squared is being multiplied by the x plus 2, and the 3 is being multiplied by the x plus 2. What do both of those have in common? They're the same. So the x plus 2 can actually be rewritten as one term, because it's being multiplied by both, right? And then what do I have left over? Well, notice how we had a 1 plus 2 here? Well, I have an x squared plus 3 here. So your goal when you have 4 terms and divide it is what you actually pull out, what you're left with, should match. And then you can put them together, and then you take the other 2 elements and then you put them in their own factoring. And that's just like what you did here, except now you have multiple terms in it. Okay, does everyone see how I did that? Alright, so let's look at 2. Let's look at 2. Alright. First of all, is there a greatest common factor in any of these?
Oh, no.
I don't think. No, it has to be all. I don't see anything. So I'm just going to divide it in half. Draw a line. Okay. So I'm going to look at this first set here and ask myself, is there a greatest common factor between those two? What is it? 9 can go into both coefficients, right? So let's do 9. And then how about the variables? What can I pull out? An m squared. Okay. Now what am I left with? I'm left with m plus 2, right? Okay. So now I'm going to look to the other side. Now the goal is to try and get an m plus 2 in parentheses on the right hand side, right? So I'm going to look at what is common that I could pull out of these two. A negative 4. If I pull out a negative 4, what am I left with? M plus 2. Okay? So you're going to use this term here as a key, as a hint to what should be pulled out to make it equal on both sides. Right? So now I can write this as 9m squared minus 4, because I'm going to bring these two terms together, and then the m plus 2's become just 1. Because it's being multiplied, I can do that. Okay? Does that make sense so far? At this point, I could say, oh, I'm done, but I'm not. There's one more factoring I could do. Does anyone see it? It's what we did after, it's what we did right here, the difference of the squares. Does anyone see it?
Yeah.
Which one?
9m, you can do.
The 9m squared minus 4?
Yeah.
Okay, so then now I have, see how I have a variable squared minus a number? I could actually, is 9m squared a perfect square? It is. What's a perfect square for 9? What values? 3m, right? 3m, 3m, and then a minus, what's the square root of 4? 2, so minus 2 plus 2, and then I bring down the m plus 2. So this can be broken into this and that, and then the m plus 2 just comes down. So that one kind of had an additional step in it. Okay? Alright, I'd like you guys to try number 3 for me. Try number 3. So in looking at this, I'm going to divide it in 2. I'm going to ask myself what's the common factor between the first set right here, and that's z squared. When I take a z squared out, I'm left with z minus 1. Okay, any questions on what I did there? Alright, so then I look to the other side, and my goal is to find z minus 1, because I'm trying to get them to be the same, right? Well, what's the greatest common factor here? 5, right? So plus 5, does that get me z minus 1? So now I just rewrite it. Since these are the same, I can rewrite that as 1 because they're being multiplied. And then I can rewrite the z squared plus the 5. Okay? At that point, I'd have to ask if I can break this down anymore, but these are not perfect squares, so I can't do anything. So that's my final answer. Okay? Alright, let's look at number 4 quickly. I'm going to divide it in half. Okay? I'm going to see what's the greatest common factor out of this term. So out of this one, it looks like it is a y cubed. And when I pull a y cubed out, I'm left with 2y minus 1. Right? Then I look at this side. What's the greatest common factor? Looks like it's going to be a 3, so I'll do plus 3. And I'm left with 2y minus 1. Because 3, and then, so if I take the 3 and multiply it to each, I should get 6y minus 3. So these are the same, so I'm going to rewrite the 2y minus 1 once, and then I can take the y cubed plus 3 and bring that down. Okay? Does that make sense? And then, so this, I can't reduce this any farther. There's not perfect square, so we can move on. That is the final answer. Questions? Okay, so we learned the greatest common factor. It's the number one thing you want to look at. Then we looked at this situation called the difference of the squares, where you have a variable, where each item here is squared, there's a minus sign in the middle. Then you can just rewrite them. Then we looked at factoring a trinomial with a leading coefficient of 1. So again, write it in standard form, pull out any greatest common factor, and then go ahead and factor it where the top is the multiple, the bottom is the addition, so your middle term has to equal that. And then we learned where it is grouping of 4 terms, where you divide it in half, pull out the greatest common factor, rewrite the similar term with what's left over. Okay?